Okay, hello everybody. Also from my side, I'm Geisler Moroder. I'm leading the subtask C in our task, and I'd like to give you a very short introduction to the task, and then give over to Adam, who will go into detail and to first results that we have out of the project. What are we doing in the part that I'm leading? We're looking into the digital world, so we're moving over to the techie part of the project. When we set up the project, when we defined the workflow, when we looked into what do we want to do, what do we want to investigate in terms of tools, of processes, of technology, we were thinking about, okay, yes, what's about digitalization of lighting? What does that mean to us? What does it include? It's the products, of course, the solutions. Looking into that, especially in the lighting, electric lighting, it's of course controls, also in the facade area, controlling daylight input, but also combining it with solar utilization, a topic of integrating PV into the facade or into the building envelope. And all that needs to be controlled. So, and we have another presentation following up by Christoph about advanced controls. It's a really important topic, dealing with all the impacts, with all the lighting requirements that we see. And happy to see that there's designers and architects here, and we already heard the topic of BIM and digital twins. It's a huge topic, and we should start from that, from the very beginning of the design process, have that, to have the whole model workflow and the whole process from the very beginning to the very end. So we look into that as well. We need to evaluate that, so we need tools to do that. Happy to be here at LVNL, where that's the cradle of great tools to do things like that. And then we also need to tell the story to the clients. So that's important to also transport the design, to transport the idea into solutions. So we'll look into that as well, and this is what Adam will talk about, the VR topic. We all do that under the big topic of decarbonization of lighting and using lighting for decarbonization of buildings. So this is basically what we're looking into. We split it up into two parts, as I said, the technology and system area and the process and design tool area. So the task is structured into four parts, into four work items, more or less, where we look into a different set of technology. We review system concepts from a literature, more academic view, and also from the market view. What is out there, what is coming up, what are we expecting, what is in the world of control systems, what is showing up, what are companies doing, what is new ideas of controlling systems, and also looking into the processes, how can continuous workflows. So I have been working for Bartenbach for a lighting design company for 12 years before I moved back to the university. The workflow in the design process is really demanding. So also looking into that here, and then looking into simulation methods and VR possibilities. I'm now giving over to Adam. One part that we started with in that design tool simulation world is looking into the potential of VR for presenting and telling the story to the client. So how is that really adopted in design practice? We know that it is coming from the fun industry, from the gaming industry, but how is it, what's the possibilities, the challenges, and also the potential, and how is it adopted in practice? So I'll give over to Adam.
Yeah, okay, thank you. So as well, it's a pleasure to be with you here and be able to present our current result. So our approach here was first to actually check what do we have. We know this is a very dynamic market. When we are talking to VR, a few months ago we had the Apple Vision that hit the market. So we decided to just check where we are, how we are using this in research, and specifically in the lighting. So we used this Task 70 as a platform to reach the experts who would answer our questions, and you can see we had some response mostly from the Central Europe, and as well with the help of Tao we got good amount of responses from China. So what we can see most of the respondents actually touched the topic of VR. They are familiar, but they don't use it too much in practice yet. And here we can see kind of comparison between the proficiency of using VR. On the left, you have the proficiency of using VR from 1 to 6, and where 6 is expert. And on the left and on the right, you can see the benefits that they see, if they see anything. And the good thing is, even the proficiency is not that high yet. The benefit of using the technology is actually noticeable, and only one person from the proficiency being close to expert 4 is actually not seeing any benefit of that. So then we asked a few questions about how they get to know VR, and most of the people, you can see, actually use it online. They are self-taught. They learn from the colleagues. So we actually as well allowed them to answer and to pick many answers, right? So we had a group of 57 people. You can see the number of the answers actually were 89. So there is that confirms that the formal training is really something that we are lucky, right? And when it comes to challenges, why they don't use it too much in the research, in their work, as one, lack of experience, which is kind of obvious with the dynamics of the VR market, lack of hardware, no time, no training that connects, and no VR specialist, and obviously somewhere there must be the lack of money for this kind of projects yet. What obviously we heard from the lighting experts is that they think the accuracy, photometric accuracy used in VR would be quite important. And here we have actually some example from Michelangelo Scorpio, who is sitting over there, that is as well using VR in his research, and we can see that this is again about photometric accuracy, that it is one of the crucial elements. This slide just shows that yes, we are using VR, but the research is on 4th place, and from those 57 people, less than 10 actually told that they use it for the research purpose. So it's really, really low. We don't have, it seems that we don't have enough resources, not enough training. People are not yet convinced here. But people claim that it will become a standard tool in architectural design. It will become a standard tool that will help and will influence design decisions as well directly in the lighting, but it must come in line with the tools that we already have. It is not something that will substitute, it's something complementary. So here we have just listed a few of the pros in context of the low carbon, high comfort lighting. So we can use VR for the visualizing the daylighting. We can use it for training, but and training regarding the general energy efficient practices, as well like on the level of management of the building, and that might be efficient from many different ways, saving money and as well low carbon elements in here. Of course, and it allows in general more users to come in there. Because yes, the experts can read graph, they can read the plans and so on, but with the tools that are enabling some kind of imagination to other people, we include others to the process. So that could be another benefit. So yeah, we will wrap up. It's actually 10 minutes perfectly. So we just would like to acknowledge some of the fundings for the people that was involved in this exercise here, and with this we wrap up. Thank you very much.
Yeah.